Hi, and welcome back to a Supply Chain Institute online resource. These are some reasons of value to use simulation as an analysis and optimization tool. 1. It can be used to plan and optimize manufacturing, supply chain, and clerical processes. 2. It provides valuable information for feasibility decision making. 3. It enables the visualization of new processes in a 3D environment. 4. It integrates graphing and results to convey results with maximum clarity. 5. Identify potential risks, constraints, and bottlenecks that would otherwise be impossible, unless during implementation, where it becomes really costly. 6. Obtain fast conclusions on the feasibility of improvements and out-of-the-box ideas. 9. It promotes a setting for collaborative work. This is really simulating the supply chain. First part of the simulation series. Your best source for simulation tutorials and references. I'm Enrique Lizaga, Head of Simulation Projects at Supply Chain Institute, and I'm very excited to help you become a simulation expert. Block 1. Really simulating the distribution center. This is the third and last video on the distribution center's inbound flows. Today we will be completing our inbound handling by enabling Skew flows and adding some policies to our putaway process to gain the benefit of visibility and traceability. These are the highlights from our last video. Remember that you can download the project assets in our webpage. You scroll down, click on the block and the session that you want to check out, scroll down, and you will have all the assets and files to be downloaded into your hard drive. Last time we achieved a pretty detailed materials receipt by using process flow functionality. Now we could really use some housekeeping. To better organize the process flow, use containers with headers. This way you are able to group activities as you consider fit. Moving a container of activities moves all the activities as well. Some people completely neglect object or activity naming, which can really help out in many situations. Coding the name of activities can help you in the debugging process. When an error comes up during execution, you will know exactly where to go. One hack for naming is granting slack for introducing unexpected activities inside the process flow. Do this by using tens, not ones, in the naming code. If you introduce a new activity, you can use a number in between, avoiding renaming all downstream activities. Remember that some models you will be creating will be used by other people. Naming is very helpful in collaborative modeling too. Use names that are familiar and descriptive. They will remind you and other potential users of what is happening exactly inside the model and how it is built. I also thought it was time to rename the 3D objects in my model. When you don't want to see the names, you can hide them and the connections in the contextual menu that pops up after you press on an empty space in the workspace view. Path networks can also be hidden by pressing the X key and then clicking on a node. See that the path network will disappear, but one node will remain in case you want to visualize the network again. Containers are also a way to organize your 3D model. I recommend using a simple plane as a container. To place other objects inside the container, you will need to select a collection of objects by holding the Shift key. They will be surrounded by a red cube outline. The second step is indicating Flexim where you want to introduce them. For this you will need the Selected Objects menu. If you don't have this available, you can activate it in the menu called View Selected Objects. Click on another object without holding the Shift key, and it will be highlighted by a yellow cube outline. This is a highlighted object. Remember that. You can then press the Move into Highlighted Object button in your menu. If you don't have it available, you can activate it in the menu called View, then Selected Object. You can flatten a container, give it a floor texture, or even change its 3D shape. The benefit is that when moved, it'll carry the inserted objects respecting their positions. So for example, it is very likely that you will have multiple receipt buffers in your distribution center. You can then move them to another part of the layout by dragging the container. I will use 2 buffers as an example. I will also insert the trailer, the door, and the pallet combiner into my container. Now we have an inbound flow with our model. The DCs, however, are not monochromatic. We can assign a stock keeping unit or product ID or part number to flow items to apply conditional material flow options, operational rules, and decision making. Go to your toolbox and add a global table, please. We could assign a SKU ID to a product manually to each flow item. But imagine modeling an Amazon facility where you can potentially have millions of SKUs. For this purpose, FlexSim allows the use of tables. In the simulator, a table works more as a database than a spreadsheet. No formulas in cells are allowed. Well, technically yes, but not now. We will use tables to store datasets that can just as well grow from small to huge without any inconvenience. My first column is a percentage, the probability of a group of products. If you add all the rows for these percentages, they must add up to 100. Let me split my view. My second column is the SKU. Be careful here, because the number is not the SKU ID per se, but rather the reference to a row in a more detailed item master. An example for you: if the SKU key returned is 4, that means that you will find the product's details, such as description, standard pack, shelf life, or other details in row 4 of the item master. To assign the SKU ID, I will add a label in an object's trigger. I chose to do it in the combiner. A trigger lets me create commands in different functions of the object. For example, when a flow item enters or when it leaves the combiner. Necessarily have to double click on the object to see the labels because my contextual menu shows it to me. But there's something that I don't like here, which is decimals. Okay, so I want to avoid the decimals. And how can I do that? I'm gonna pull up my combiner and I'm gonna do it by truncating the value as you would do in an Excel spreadsheet. So I could cut it and I will leave it there. And I will go to the beginning of the sentence and say math dot trunk. Why? Because it will call for the math functions and a bunch of options we have there with the math functions, and we're gonna call this command, which is called truncate the value, and we're gonna close the parentheses. Remember to do this. I'm gonna open this window a little more so that you see what happens with the parentheses. As I get closer, it's gonna highlight both the left parentheses and the right parentheses. That means that you have closed it correctly. If you don't do that, it's gonna show you an error message. So be sure to be careful there. So let's see what happens. It's gonna get rid of the decimals, and right now my SKU should be perfectly. There we go. So let's run it, and I'm gonna test a couple. Just inspect a couple of these palettes. This one is a 3, SKU number 6, SKU number 4, SKU number 9, SKU number 8. Perfect. So So we're going to have anything between 1 and 15, I believe. Yeah. So now we have skews. And the beautiful thing about it is, now we want to use that skew information to send to a specific location in the rack. The pane slot tool allows us to assign an allowed skew ID for each of the rack slots. Only the specified skew ID numbers will be allowed in. First, go to the properties and configure the value that each color will represent. Second, paint the slots that will receive this skew ID number. As you see for items AA and A, I will use 2 slots. It will act as a filter. The beauty of this tool is the visual interaction. Paint all the rack slots with their permitted skew ID number values. Because we have 15 skews, we will use 15 different numbers. We don't need such a large rack, so I'm gonna resize it. How do we use our new configuration? Go to the rack slot assignment strategy and select option called matching labels. We want to match the slot type with the new label we just created for the products. It is called Skew Key, remember. Is there a way to audit this? Of course, we can stop the model, and then this should be for Skew 1. These slots should be reserved for Skew 2. So I see that, yep, this one's faster. This is Skew 3, Skew 4, 5, 6, 7, 8. Yep, there we go. It's routing the pallets to the adequate location. This is very important in a warehouse. Static locations, but it is possible that we might want to use dynamic locations, and that can be used too. We're not going to do it right now, but it is possible. So the last thing that I want to do with this simple model is, because right now I do have, let's say, a way of routing products inside the warehouse, but now I also want to track them. Want to see where they are and where they've been. So what I'm going to do is, here in the rack, I'm going to go ahead and use the default scheme for mapping, and my zone is going to be, for example, N, aisle number Z, and I'm going to keep these numbers right here. Okay, and in the triggers tab, remember that we can enable different or additional commands that are going to be executed when something happens. So whenever a slot is assigned, I want a label, right? That is called, for example, location, rack location. Okay. You don't need to panic. There's no need to learn all of these commands and go and devour the user's manual. Eventually you'll become comfortable with all the different commands that there are. We're gonna create a label for the item that's called rack location, and we're gonna print there the slot address. So let's test that, see what happens. Something I really like about this version is that even though it's already modeling and you move it around, it moves and it doesn't freeze. So there you go. Let's see what happened here. Okay, so look at this. We have a label that's called Skew key, so we know that it's Skew number 9, and this pallet has been placed in the zone N, aisle Z, bay 2, level 4, slot 1. So this is perfect because we can track basically where all the pallets have been. First, we created a basic flow. Second, we detailed the process visuals. Third, we created a detailed inspection process at the buffer. Fourth, we configured a rack location. Fifth, we differentiated Skew material flow. And last, established a location address system. Here are the highlights for today's video. So stay with us. On our next video, we will move on into the outbound flows, specifically the order picking process. We will create a forward picking area that can be scaled from a few to any number of picking locations. We will be able to replicate the behavior of orders by using an order profile. Picking operations are full of exceptions, so you will learn how to handle them, which will be the first problem set you will have to solve. This is really simulating the distribution center, the first block of really simulating the supply chain, part of Supply Chain's simulation series. Subscribe to our channel and activate notifications so you don't miss the next session, where we will continue to build simulation skills and better knowledge of the software. Cheers.